Let's go over the diffusion and osmosis problems. Before we start, I like to do a little brain dump of what the vocabulary terms mean. So if something is hypertonic, this means that we have more solute, and because we have more solute, we would then have less water. If something is hypotonic, we have less solute and therefore more water. So let's take a look at our problems here. So it says osmosis is the diffusion of water molecules. Water moves from an area of high concentration to low. So remember, because this is a form of passive transport, it's always going to move from high to low. So it says circle which solution has a higher water concentration. So when I take a look at example 1, for example 1, I see that this first one, 0.7 m NaCl, and NaCl is salt, compared to solution B has a 0.3 m NaCl. So in solution A, we have a higher concentration of solute and therefore a lower concentration of water. So in solution B, we have a lower concentration of solute and therefore a higher concentration of water. And if we wanted to label these, we could label solution B as the H, solution A as the L, because remember that's always labeling our water. And so then the answer is that we have a higher concentration of water in solution B for this one. If we take a look at the next one, in the next one, example 2, we have 1.3 compared to 2. So we have a lower solute in solution A and therefore higher water compared to solution B, where we have a higher solute and therefore a lower water. So for example 2, solution A is our high concentration of water. Hopefully you see the pattern. So for example 3, in solution A, we have a 0.05 molar concentration of NaCl, which is a higher concentration of the solute than solution B, which is 0.02 molar NaCl. Therefore, our higher concentration of water would be in our lower solute concentration. So solution B would have our higher water concentration. Okay, let's look at example 2. So in example 2, it says draw arrows into or out of the cell indicating in which there would be a net movement of water. So again, we're talking osmosis, so we're talking about the movement of water, which is going to be from high to low. So whenever we take a look at this first cell and solution, we have a 0.8 molarity salt solution outside the cell and a 0.5 solution inside the cell. So because outside has a higher solute concentration, it's going to have a low concentration of water. And inside the cell, we have the low concentration of solute, therefore the high concentration of water. So our net movement in this case is going to be out of the cell. The next one you could look at is, oh, it's just backwards, but let's think about it over again. So here outside the cell, we have the low concentration of solute, therefore the high concentration of water. Inside the cell, we have the high concentration of solute, therefore the low concentration of water. So this time our water is going to be moving into the cell. And the last one, because our concentrations of salt are equal inside and out of the cell, this would be an example of an isotonic solution. So water would be moving in and out of the cell. You could use the double-sided arrow, or you could draw an arrow going in and an arrow going out. Either of those would be the great answer there. Example 3. It says, here's a tank with 2 solutions, A and B, that are separated by a semi-permeable membrane, just like a cell membrane. It says glucose cannot pass through the membrane. So will water move from A to B or B to A? And draw the arrow. So here in A, you can see we have a 1 molar glucose solution, and in B, we have a 0.5 molar glucose solution. So in the 1 molar, this would be high solute and therefore low water. In the 0.5, this is our low solute, therefore high concentration of water. So water would move from B to A. So if water is moving, how does this change the water level? This would make the water level in A rise and the water level in B go down. So we could write that A would go up, B would go down. Number 5, solute is defined as the minor component in a solution which is dissolved in the solvent. So in a solution of water, the solute would be salt, and the solvent is water because we have a lower amount of salt compared to the water. This is a great little review of our terms that we talked about on the front. Hypo means lower solute, therefore high water. Hypertonic is a greater solute, therefore low water. And isotonic is equal. So on number 6, we want to label the solutions as hyper, hypo, or isotonic. So on yours, your cell is right here, and it's 0.09 sucrose. So when I look at this, the easiest one to find is the isotonic. So the isotonic is where we have the equal solute concentration. So that would be the 0.09. So this solution is isotonic. Then I want to think about it in terms of having the lower solute concentration are all our hypotonic. So I want to find all the numbers that are below 0.09. Those are going to be hypotonic. So that would be 0.003. And again, that's hypotonic because it's lower than 0.09. And the other number that's below 0.09 would be 0.045. So that one would be hypotonic. And I think that's it. Hypertonic is having a greater solute concentration. So besides just the ones that are left, if we think about it, 0.75 is greater than 0.09. So this would be hypertonic. And 1.38 is also greater than 0.09. So this would be hypertonic.